and start on a lab practical review. Lab practical review I will do next week, most of it. However, if you look at the announcements, and the announcement will say something very interesting. I dedicated several, and it's not only for you guys, it will be for all of the biology classes, not only mine, but everybody else. Every Friday before the lab practical, meaning Friday, well, tomorrow, the 10th, Friday, October 8th, Friday, October 29th, and November 19th. I will be in the actual Bio2 lab, which is S1 381, South Campus, first building, science building, and you're going on the third floor. Room 381, it's actually Bio2 lab. And it will be between 10 to 11:30, maybe till 12, somewhere in that area. You're coming in, you're looking at some of the microscopes, the actual, well, of the whole things which we covered, the skulls, the Hardy-Weinberg, the bacteria, protists, algae, the herbarium of the algae. Then we are talk about the fungi. All of that will be available, and you can literally touch it if you have a chance. If you don't, then shoot me an email. I have the online conference hours, and this is where I'm trying to answer the emails. If you still don't understand, and I know a couple of you took advantage of that, you shoot me email like, hey, I don't understand this, can we do a quick Zoom? And I'm like, sure, yeah, let's do a quick Zoom, and then we'll figure it out when to do the quick Zoom, and probably I can do the one-on-one regarding any kind of questions you might have about the class. So the rest of the lab practical review we'll do next Tuesday, well, next class. Now let's go into the course content, and in the course content you will find the group project folder, right? But before going into your group project folder, there is a cladogram activity which is due 19th, so 2 weeks from now. Well, week and a half technically speaking. So on 19th, all of your homework, all of your virtual labs, this particular assignment, and I think the Becoming Human episode 1 is due. So it's the very end of the unit 1. So I would recommend you to do as much as possible during this particular weekend, because it will be also kind of refresh your memory on what we covered during those few weeks. Okay, so don't wait until actually September 19th. It will be a lot. You will be overwhelmed, and then you're like, I need the extension. Why? Well, because I didn't do it in one day. I'm like, well, I can send it to quite a large amount of time to do it. Anyway, let me kind of show you the cladogram activity. If you're pulling it up, so here we have enable editing, and that's basically cladograms. We talk a little bit about the cladograms regarding when we're talking about the evolution. Essentially what we have is the group of organisms and something which is known as the derivative traits. Traits which are breaking, splitting those organisms apart. For example, all of those organisms, all of them, you see, they're starting with that branch which says vertebrates. It means that all of those creatures have the vertebrates. They have a vertebral column. Everything's good. It's a common trait for all of that particular groups, because they had at some point of time a common ancestor. But now we're looking at the two branches are splitting up. We have one with the sharks and everybody else. And the derivative trait, the trait which is separating sharks from everything else, is a bony skeleton, meaning that for all of those creatures right here, to the right side, or to the right branches, all of them have a bony skeleton. What about sharks? Well, apparently they don't. What do they have? They have cartilage. That's why they have there is a special group of fish where sharks belongs to, known as a cartilage fish. And then you're moving on, and then of course we'll have 4 limbs. So now all of those creatures have 4 limbs, except that one. That one, ray fin fishes, they have fins and it's not 4 limbs. And then we're looking at the amniotic egg. Amphibians do not have. Everybody else, including the primates or mammals, I should say, have the amniotic egg. You can say we don't have the amniotic egg. Yes, we do. In the primates or in the mammals, we have an amniotic egg. It does not mean that we have a shell, because later on the egg will, whenever it will get fertilized, it will embed itself into the uterus of a female, and this is where it will start growing. While those creatures, what they will do, they lay eggs and they are protected with a thick layer and so on and so forth. I'm not sharing the screen. Good one. Thank you. So in this particular case, again, we're looking at this cladogram tree, right? And again, we're looking at the sharks, at the ray and fin fishes, derivatives. All of those are available to you. And then whenever you're looking at the questions, which organism in the cladogram have hair? So what, in order to answer that, you're looking for the trait hair right here. Above from that particular branch will have hair. So above we have primates, but also we have rabbits, well, rodents and rabbits. What about crocodiles? They don't have hair. Why not? Because we split in the amniotic egg. We split on the hair and the orbital, post-orbital openings, the holes, so to speak. All right, makes sense? So which organisms have bony skeleton? Again, you're looking for the bony skeleton, and all of them except the sharks. Or you can say fin fishes, ray fin fish, amphibians, primates, rodents, crocodiles, the birds and dinosaurs, and so on. That's usually not a huge problem among the students. The next part, whenever you're actually constructing the cladogram, this is when it becomes problematic. All right. So here we have traits, the creatures. You're welcome to look it up, those particular creatures online if needed, because like some of the students like, what is lamprey? Well, it's some sort of, it's a very special type of the fish known as the jawless fish. It looks like slimy, does not have the scales, etc. So in this particular case, the first trait, does it have the nerve cord? Yes. Does lamprey has it? Yes. Monkey? Yes. Bullfrog? Yes. Human? Yes. Pink turtle? Yes. Tuna? Yes. So all of them has that. So that's a common trait for everybody. Paired appendages and vertebral column. Kangaroo has, lamprey doesn't. Everybody else will have. So see, this is a derivative trait. This is where the lamprey will split the rest of them. Paired legs. Kangaroo does have it. What about monkey? Yes. Oops. Bullfrog, yes. Human, paired legs generally, yes. Snapping turtle, yes. Tuna, no. Tuna has fins, they paired, but it also has the tail fin and so on and so forth. Now, amniotic sac. Kangaroo will have it. Lamprey already don't. Rhesus monkey have it. Bullfrog not. Human and snapping turtle does have it. Now, mammary glands. Kangaroo is a mammal. Monkey is a mammal. Bullfrog. Humans do have it. Snapping turtle is not a mammal. It's a reptile. Now, placenta. Kangaroo not placenta. It's something which is known as the marsupials. So rhesus monkey will have it. Humans will have it. Everything is great. Now, last one, canine. Should be only, no. Yeah. Canine teeth short, foraminum magnum is forward, closer to the center. That would be human. So now you are color of X, 1, 2, 3, 4, 5, 5, only one. We have here 6, right? 6. Here we have 3. Here we have 7. Here we have, and here we have 2. You see, none of the organisms have exactly the same number. Meaning what? If you ended up with the organism having, let's say, 6 and 6, you can say, well, kangaroo is the mammal and it's supposed to have 6 as well. So now you have kangaroo, monkey, both of them having 6. It means that you did something wrong, and there is no 5. It means you're doing wrong. None of the organisms will have a same number of the traits as the other. I specifically designed, well, I adopted that one, but the whole cladogram is specifically designed to have a different number of traits. Okay, so if you ended up with the same number, you did something wrong, look it up, Google it, Yahoo it, whatever, or you can shoot me a quick email and say, hey, here's my data table, and I have same questions, same traits for such and such organism. Print screen it, send it to me, and I can tell, well, look it up this and look it up that, and I'll try to, well, I will not give you the direct answer right away, but I'll guide you to the direct answer. All right. Now, after doing this, you'll need to do the Venn diagram. And there is 2 ways how the students are trying to do. They starting with a lamprey right here and then going out from the smaller box to the larger box, which is incorrect, because here the largest box means it's include everything else. So lamprey would be right here. You start adding here, you start typing it right there whenever you're inserting the text box, and you're putting what are you putting? You're putting the lamprey, dorsal nerve cord, and a notochord. Means that that particular, well, you're actually putting the trait cord, right? Like it was here, lamprey and then notochord. It means that everybody else inside of that large box will have the notochord and nerve cord and so on. So from the most inclusive seed, the large to the least inclusive. So you're starting with a lamprey, you'll finish hopefully with a human. Now you will need to do this thing, and that's basically exactly what you're taking that particular diagram, a Venn diagram, and you are putting it in the form of the graph, or essentially cladogram. What you will do, start with the first trait, which will be vertebral column, and everybody on that graph on a cladogram will have an organism known as a lamprey coming out. Why? Because there then will have a paired, the next trait, paired appendages. A lamprey doesn't have paired appendages, so it will stay behind or below the graph. Kind of makes sense? So yes, try that one out, and then you will have pretty much the same thing. Well, you will need to three types of the information, which you can go from the cladogram, and then you will need to place on the same cladogram those particular 3 new discovered types of, and then you will do the same type of table as we did right here. You can do it exactly the same way, but now you're looking at the a slightly different number of the creature: amoeba, shark, coral, frog, wasp, dolphin, sponge, eagle. Some of them vertebrates, some of them invertebrates, some of them multicellular, some of them not. Remember, amoeba is a single cellular. Is it eukaryote? All of them are eukaryote, not multicellular. So here we go. No. Number of traits here will be only 1. It's eukaryote. The issues because it's not multicellular, etc. So, and again, we haven't covered any of those animals in our class yet. So look it up, and again, the number of ancestor should be unique to each of those particular creatures. I specifically designed so you will have a unique number. Now, one of the most common mistakes which is happening right here. Some students are not really sure what placenta hair means. There should be a comma right here. Okay, placenta and or hair. And which brings us to that particular guy, a dolphin. By dolphin, we're talking about the mammal dolphin. Makes sense? Does the mammal dolphins have hair? Well, as the adults know, but whenever they just born little pups, the dolphins, they have several hairs on their nose. Apparently, well, something which is called vibrissus. This is the hair which allows them to find and feed on the milk from the female. And later on, they will fall off. But even adults dolphins, they will have kind of tiny little bitty dots on the nose where the hair used to be. All right. So placenta, comma, hair. Please make that particular change. All right, now you will do the cladogram, exactly the same thing as you had it right here. You might want to move that particular cladogram. It will be really extensive on the next page. And please do not forget please do not forget the question, compare and contrast convergent and divergent evolution. Talk to me about convergent and divergent evolution. And that's pretty much all on a cladogram assignment. All right. And again, any questions, any problems? I'm staying after the labs. Usually you can feel free to ask me about that. Now, common assignment of group project, same thing. You already have it posted. Let me pull it out right there, group project, also known as a common assignment. So you're going right here in the course content, and there is 3 files. One of them is the blue file, and 2 of them are red and orange. This is what you will be submitting. This is the common assignment. If you click on that, it will give you the this particular file right here with the picture of the Florida panther and all kinds of descriptions talking about how it's been done, etc. All of them, it has all of the 14 questions as the common assignment. However, I do not need for you to upload all that. Please do not upload this particular form, because the form which you need to upload is much shorter, talking about the volumes. So the form which you will be submitting is actually look like, let's see, I need to close that one down. Let's see. That's a teamwork. So next, this one. No, it's still teamwork. Here we go. You see it's submitted on the blackboard. I don't need the pictures. I don't need the explanations. All I need to do is the answers on number 1, 1A, 1B. We'll do it today. Question number 2, A, B, and so on and so forth. Now, I need those particular. This is where you will be answering. So today, hopefully, we'll be able to do first 5 questions together. I'll refresh your memory on the P and Q and P squared 2PQ plus Q squared equal 1, all that stuff, equilibrium again. And then starting with the question number 6, all the way to 14, you will be doing it in the groups. How the groups will be set it up? Well, first, if you have some sort of partners in mind, I need at least 3 people per group. If you have and no more than 4, so we're not like having a group of 15 people all together. No, 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 no. 3 to 4, it's the top we can have. So if you have friends in your class, or if you know somebody, you're going to the same school or anything like that, send me the email as soon as possible, because tomorrow morning, Friday, I will go over the class and I will break you down into the groups, 3 or 4 people per group. And if you need to be moved, to change, to anything like that, let me know as soon as possible. Then I will rearrange the group if needed. But basically, I will be breaking down into the groups, and you will find that there will be a link available to your group on the Blackboard, and so you can get into the group and email everybody, and then you can go and do whatever you need to do. You can either use the emails, whatever the other apps you want to use, GroupMe or what have you. So now, here's the several questions, and I will show you. But question number 6: summarize 3 major problems with the population size. The issue is that the Florida panther population become very small, and you need to tell me which particular 3 major problems with the population size you think is important. You think is important, not your group. That particular question, as well as the summary number 7 and so on, needs to be answered individually. I don't care about the numbers. The numbers later on when you will be calculating, like for example, if the population of mountain lions, 9% of individuals suffer, here you'll have some sort of calculation. Those particular calculations might be exactly the same within the group. Hopefully they are. If they're not, then it means that there is some sort of undergoing conflict. But the personal opinion needs to be individualized. Meaning it's your personal opinion. Tell me what you think is important. And for that, I have that part, like very important question 7, 8, and 9B must be answered individually. Can they be similar? Yes, I don't mind if they are similar. You agree with the group, you discuss within the group. Here's our 3 major problems. I think with a small population, blah 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 and blah. Well, it's not due March 7th, a month, so it's due October 10th, right? I think so. I think it's stated, but you have a month to do it. So in any case, but the main idea is that those particular questions need to be answered individually. I don't want to see 2 identical answers. I'll see 2 identical answers, that's 0, and you don't want a 0. Please, that's like that's a big project. All right, so keep that one in mind. Again, PDF, all that particular stuff. Now, team evaluation. Messenger, don't kill the messenger. But the way a particular team evaluation form, but in a team evaluation form, let me pull it out really quickly. Here we go. Team evaluation form. You're putting your name, you're putting the lab use. That will be a Panther project, lab days and time, that one. Self-evaluation. First of all, you will tell me about yourself, that you are absolutely amazing. What would be the absolutely amazing? 1, not 5. I had students saying, I will rate myself. I did absolutely everything. I was this spearheading the whole project. I did so much. I invested so much time. That's why I will rate myself as 5. Like 5, you did absolutely nothing. So keep that in mind, please. Okay. 1 is is amazing. 5 is did nothing. So once again, I didn't devise that. That's somewhere up in the college has been done. Now, then you will be evaluating, and your members, your team members will not see it. I will see it, and that's pretty much it. So please to be as honest as possible about and the evaluation of your members. Now, another thing, very important, happened to me in online environment as well as in the face-to-face. I'm reading the team evaluation and I will read it. That's I'm not just like, oh, I submitted, here we go, 15 points. It's 15 out of 15. I'm like, no. I'll be reading. And I'm reading one of the team evaluation, and they're like, Margie did an excellent job. I'm like, I really don't know who is the person talking about, because I don't have a Margie on my list. And then I'm going down, and then it's like, the Andrew did absolutely great. He was so helpful, etc., etc., etc. I'm like, there's no Andrew in this group or in this class, period. So I'm emailing the students. Actually, it was a face-to-face class. I'm like, who is Margie? Who is Andrew? Who are you talking about? And I feel like, well, I didn't know the name of my team members, so I made them up. I'm like, so you evaluating made up team members? You're like, well, I decided that this guy is named Andrew and that girl is Margie. I'm like, please do the actual members. You have a group, ask the question, what are your names? And let's not do the imaginary team members. I know imaginary team members, you will do all good, everything will be great. Okay, so that's about team evaluation, and this is where you will be able to where you will be able to submit. This is particular piece of paper or document. This is the to be submitted on a Blackboard. I don't need the whole entire project like this. That one, as soon as I'll see picture, I'm deducting points right away. It means that all the direction. This one, it's for your reading what exactly is happening with the Florida Panther. This one is the smaller form. And also, if you'll take a look on the smaller form, so to speak, let me pull it out. Let me go back. On that one, it also has rubric. At the very end of this particular reading assignment, it has rubric, how many points each question weighs. Today we'll do first 5, hopefully, meaning that you will have about 1/3, 36 points, 1/3 of the project done with my help. All right, any questions, any problems at this particular moment before I'll actually go into the project, and we'll talk about the issues there. All right, well, let's go into the project. Let me close that. Don't really need to save any of that. So let's see. I'll pull it out, this particular document, and I'll kind of quickly explain. Here we have a charismatic species, really nice, Florida Panther, and it is highly endangered species. Why? There is several things happening. Of course, as you might understand, Florida Panther will be found where? In Florida. And because people are moving in Florida en masse, we are increasing the presence there. We are changing the environment. We're building the cities. We build the biggest parks, recreational parks in the heart of Florida. Also, we build one of the largest launch pads to launch the rockets into the space there. So starting from the beginning of last century to this particular century, the environment changed drastically. There is way too many people there. As a result, we are breaking down the population of that particular creature, and we also were at some point of time actively hunting those creatures. So what we start seeing in mid-90s, where the panther left to approximately 20 to 30 individuals in the whole entire world, not only in Florida, but this is where they belong to. And if you think about it, Orlando, right? The recreational park capital of the world, besides the Disney World, the largest 4 or 5 parks now, right? There is also the Universal, there is the Legoland. I think last time I've been there 2019. I have 2 kids, so I have to go there periodically. But in this particular case, I think near the Orlando area, we have overall 30 plus different parks only. Millions of people every year coming in, so you have to have the infrastructure to support all of those millions of people there. So as a result, the creatures are suffering, specifically big predators. So in this particular case, what we'll ended up with is that they shrunk to only handful of the animals. And remember, as we did in our lab number 1, whenever we had 30 bunnies and half of them, about 43, I think 43 and 57%, 43 of them, 43% were naked, furless bunnies, and then 57% of the populations were furred. Everything was going good until we had some sort of crisis, Siberia, and then the number of the furless bunnies shrunk to pretty much nil, or actually specifically the frequency of that particular frequency of that particular genotype drastically reduced from 43, dropped down right away. Remember that? So this is one of the problems with the small population. You're eliminating one individual, one panther, and you're taking 1/3, well, 3% of the overall genotype. So that's being said, this is the sad story about the whole thing. It's in 90s, yes, mid 90s, we had that particular issue. Now the Florida panther is still in danger, still threatened, but it's doing much, much, much better. And one of those particular things are the reintroduction or introduction of Texas cougars, and we'll talk about that momentarily. So let's go and talk about question number 1. Given the passing of alleles into a gametes is random, if we observe one gamete, and the gametes, of course, egosperm, of an individual in a specific gene or locus. So what does it mean? It means that if we're looking at the egg, for example, or sperm, doesn't really matter, and we're looking at the specific gene with a capital A, or gene with a capital B, or gene with a lowercase f, whatever the gene might be. So now, what is the probability that this allele in the gametes is from father of individual? All right, so every individual, especially in mammals, will have a mother and father, male and a female, which contributing, right, pretty much equally. Meaning that 50% of the genes comes from the father, 50% of genes comes from the mother. That's not entirely correct because, for example, if you talk about the mitochondrial genes, they come only from the mothers, but we're not going into that. We're talking about, let's say, my genes. Half of them came from my mother and half of them came from my father. That's pretty much it. Whatever the biological mother, whatever the biological father I had at some point of time. So no, let's go back. What is the probability? So 1/2 individuals, so 1/2. The probability would be point. It will be 1/2, or you can do it into a 0.5, right? Which is, if you don't like the fractions, one of my sons, he hates fractions right now. He's math and he's like, I hate fractions. So anyway, or you can convert it right away into the percentage. How you can do the percentages? Oh, very simple. You're taking the whatever number you have, the decimal 0.05, change that, 0.05, and you're multiplying by 100%, because 100% is 9, and that would give us a 50%. So that one is already an answer. If you don't like fractions, you can go with the decimal. If you don't like decimal or fractions, you can change to the percentages. The main idea is that you will stay consistent. I don't really care if you'll do it with the fractions, and yes, not everybody likes the fractions, or in decimals, or in the percentages, whichever, as long as you're keeping consistent. What does it mean, keeping consistent? Well, let's take a look on a question B. What is the probability that allele or gamete from this particular came from a mother of individual? So from father is 50%, so from the mother, the other half, right? So let's say you answered, my answer is 50%. And then here you decide, well, today I'll do the fraction. My answer is 1/2. You see inconsistency. Here you're talking about the percentages, here you're talking about fractions. Not very nice. Try to be consistent. So if your answer is 50%, so the second part should be in 50%. If it goes into fractions, it goes into fractions. Make sense? If it goes into a decimal, then it goes as a decimal. So in this particular case, let's see, oops, 1/2, also known, or it will be 0.5 or 50%. So either of those works, whichever you prefer, or you can keep it as it is. But everywhere 50% or 0.5 or 1.5 came from. Yes, no, maybe. Okay, so all good so far. So question number 1 done, and if you look at the rubric, it's like 3 points, and we have another 3 points, so 6 points already, almost 10% of your grade. It's 85 points for this particular assignment. All right, now let's look at the question number 2. In the figure 2, what is the frequency of allele A1? And we know it's P, means dominant allele, A1, right here, in the population. All right, well let's kind of figure it out how we can answer that. We're looking for a frequency. So frequency of aka P, right? This is what we don't know. And I would highly recommend you to write down what I don't know. I'm trying to find this. This is what I'm looking for. All right, well, if you look right here, let's see. If you remember what we did in the class, in the lab, actually in the lab number 1, whenever we were calculating the frequency, or P was equal, lowercase p, lowercase p was equal number of alleles dominant over total number of alleles. So now all we need to do is put it in the how many A1s do we have? We have 1, 2, 3, 4, 5, and 6. So we have 6. Yes, 0.6 is the correct answer. But this is where the 0.6 coming from. 6 dominant alleles over how many alleles total we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10, also known as point of 0.6. See, everybody see that? You can also say, oh, or it is 60%. Whichever. I prefer for you to keep it in decimal unless it starts what the percentages. But P typically goes in the into a decimal because remember P plus Q equal 1. All right. So in this particular case, we calculated frequency. We were looking for frequency A1, also known as a P, and now we know how to do it based on whatever we learned before in the lab. Now let's take a look on this one. In figure 2, what is the frequency of allele A2Q? So this is what you're looking for. Frequency, of course, it's frequency of A2. A2 known as Q. If you know what you're looking for, and you remember that the Q is equal, or Q, equal number of recessive alleles over total number of alleles would be equal to, we have how many A2s total we have? No A2s, no A2s, 1 A2, 2 A2s, 3 and 4 A2s. So we have 4 divided, and we still have the same population, so it has to be divided by 10. And that would be, as I have a student pointing it out, 0.4. Or if you want to, if you really like percentages, you can say it's 40%. Now you see it says wait, stop and wait, etc. I would highly recommend it, not necessary, but highly recommend to double check if you did your math correctly. You remember that P plus Q equal 1. So you stop, you wait, you're done with your calculations, and all you need to do is double check yourself. Because if you did something wrong, it means that you will be losing 3 or even more points. So P plus Q have to be equal 1. Let's double check. Our P is 0.6. Double check, always double check, because sometimes I had students like 6 over 10 and then it become 60. And then he or she answered, I have 60 and then my P is 60 and my Q is 0.4. I'm like, how it's possible? It's definitely over. Oh, I mistakenly, instead of 6 divided by 10, I did the 6 multiplied by 10. So that's why I'm telling you guys, it's a really good time after you did the question, pause it and see if your numbers is actually matching. And this is what I'm doing. Takes a couple of seconds. 0.6 plus 0.4 indeed will be equal 1. So we solved the problem number 2 correctly. Everything is great. We can move on. You can read if you want to, but again, in this particular, all of the alleles either will be in the dominant or recessive forms. And again, if you look at the percentages, 60% plus 40% will give us 100%. If you made made a mistake and calculated or type at 70, and here you'll have 40, then you'll end up with 110%. That's impossible. So now, question number 3. Given that the population depicted in a figure 2 reproduces to make a generation, so we have those ones are combining the genes reproduce, what would be the frequencies? Now, instead of P and Q, we're looking to P square, Q square, and 2PQ. So now in this particular case, let's take a look. What is the probability of an individual of in the offspring generation be homozygous? P square. All right, this is what I'm looking for, P square, right? I'll do this. Yeah. So P square. P square is unknown. I don't know my P square. But guess what? I know that P is equal 0.6. Therefore, P square will be equal to 0.6. Oops. Wait. Square. And that will give us 0.36. Any questions, any problems from that? Everybody understood where I got 0.6 from and where I got 0.36. Because if I'll do a calculator right here, 0.6 times 0.6 will give me 0.36. All right. Moving on. What is the probability of Q square for? So I'm looking for Q square is unknown. I know our Q from the calculations before was 0.4. Q square will be equal to 0.4 squared, which will give me 0.16. Double check on the calculator, so I will not 0.4 times 0.4.16, or you can do 0.4 squared, 0.16. All right. Last but not least, I'm looking for 2PQ. 2PQ is right now unknown. I know that the P is equal to 0.6 and Q is equal to 0.4. Therefore, 2PQ will be equal to 2 times, that I should say P right here. It says P. 2 times 0.6 times 0.4, and that would be equal. 2 times 0.6 will be 1.2, and 1.2 times 0.4 will give me 0.48. Double checking on the calculator. 2 times 0.6, 0.4. I'm finished. But then it says, wait. What do I need to wait for? I'll check. P squared plus 2PQ plus Q squared have to be equal 1. Let me double check. My P squared was 0.36 plus my 2PQ was 0.48 plus my Q squared I received 0.16. Is it equal to 1 or not? Well, again, right here. 0.36 plus 48 plus 0.16 equal 1. Yes, I did everything correctly. I would highly recommend, once again, highly recommend to double check your numbers, because sometimes you're in a zone, you're making minute mistake, and then everything else, especially if you made the mistake, let's say in a P, and then everything else not following into the correct numbers. All right. So moving on. Any questions, any problems on where I got any of those numbers? Straightforward, nothing to do it as long as you're following the, basically, you know what you're looking for, and you just figuring it out, basically plug and chug. Not hard at all. Pay attention though. All right, now here is talking about our four Panthers, and the problem was that they start seeing the increase of some of the negative genes, something which is known as the deleterious genes. So populations is lose the alleles and forced to inbreeding. As soon as we'll start looking at the inbreeding, we start seeing the some of the negative alleles picking up more often. So now, question number 4. Given that the population we used in the example above, so the same population, 75 panthers, what is the probability of allele A1 become fixed in the population? All right, well, let's kind of start with what we need to find. A1 fixed. This is what we figured it out. Like, I don't know what fixed means. If you'll read, all right, about any given point in time, the probability that allele eventually become fixed in the population is equal to its proportion in the population, equal to its proportion. Ah, okay, all right, that's good. So it will be equal to its proportion. So A1 fixed is equal to what? Fixing of A1. And we already calculated frequency of A1 before, which was right here. And the frequency of A1 was 0.6. I can also say equal P, and it's equal 0.6. Where I got that? From question number 2. All right? Or I should say 2A. This is why I'm asking you to stop and double check every single step, because say if I made a mistake right here, I would inevitably will make it, and as a result I will make mistake right there, and it's all 3 points. So I made mistake right there, then here and there, so I'll see 9 points off, right, because I didn't calculate one of those questions correctly. That's why it's worth it to stop and double check yourself. You might say, oh, I did everything, I'm perfect. Yes, I know. And you don't want to check yourself. Don't check yourself. Check the math of your lab partners. The unofficial rule number 1 in the lab, right? Always blame your partner. Number 2, always blame your instructor. So in this particular case, like, oh, I didn't calculate it, my partner did. Well, check your partner. Now I'm your partner. Let's stop and check it. Let's check if I calculated it correctly. Make sense? Hopefully you got the importance of stopping and enjoy the moment. Double check that you did it correctly. Now, what is the probability that allele A1 will disappear? A1 disappear, right? I don't know what it is, but let's kind of read. And the probability that it will disappear from the population is exactly 1 minus its proportion right here. So A1 disappear will be equal 1 minus A1 fixed, which will be equal 1 minus 0.6. And that would be equal to, I can use a calculator, you can double check me, but I'm almost certain it's a 0.4. I can do that type of math in my head. So 60% of that, or 0.6, that it will be fixed, stay within the population, everybody in population will have it, or 40% in a small population, such as 5 panthers, that it will disappear fully, completely. None of the members of the population will have that particular gene. That's one of the huge problem with small populations. All right, now, what is the probability that allele A2 now, A2 will be fixed. A2 fixed equal frequency of A2, which is technically Q, and which we calculated as 0.4 from question 2B. Didn't have to do any calculations whatsoever. All right. Next one, D and A2 disappear. What would be the probability of that? It will disappear. A2 disappear will be equal 1 minus A2 fixed, which we already calculated. It will be 1 minus 0.4, which will become 0.6. Meaning that A2, the recessive allele, has 60% of disappearing in this particular population. Disappearing means none of the next generation will have that particular trait. Is it good? Is it bad? Well, it's on the situation. For example, my dog has something which is known as the gene to produce vitamin C. and it's producing as well as a cat. Cat somewhere. A cat is outside. So anyway, what does it mean? It means that they don't have to consume vitamin C. They have a specific gene, and the organism producing as much vitamin C as the organism need at this particular moment. At some point of time, our ancestors had that particular gene, and they also had a defective gene, which is starting to code the vitamin C, and then it's not producing it. All of us, the whole entire human race, so to speak, have that defective gene for vitamin C. The production of vitamin C gene has disappeared from our population. You can say that's not good. Yeah, I guess it's not good. That's why we have scurvy, the deficiency of the vitamin C. We have to eat fruits and vegetables and all kinds of good things. Anyway, so this is question number 4. Any questions? Any issues? Where are the numbers coming from? All right, now inbreeding. Inbreeding is when we have close related individuals producing the babies. And in this particular case, close related individuals will have the very close, not identical, but very close set of those particular genes. As a result, we'll start seeing some of the genes completely being missing out, or versions of the genes, dominant or recessive alleles. We had the inbreeding going on in some of the royal family, that the royals have to marry royals. As a result, we see some of the genetic diseases being transferred from one royal family to another. For example, royal family, the British royal family, I think Queen Victoria had, she was a carrier of the genetic disease known as the hemophily. Hemophily is basically non-coagulation of blood, well, plus a few other issues, but the blood will not be coagulating, will not stop. So you can literally, the person with the hemophily, I'm grossly exaggerating, but literally can die from minute cut, small cut. So in this particular case, started in a British royal family, and then it starts spreading out into a different royal families, including the Russian royal family. As a matter of fact, the last prince, the Prince Alexei, he was hemophilic. Victoria was not hemophilic herself. She was a carrier for that particular gene, but her granddaughter, I think, was the mother of Alexei, and she gave that particular gene to the last prince in royal families. And then, of course, it's a tragic story. All of them has been killed, etc. But this is the problem with inbreeding. We start seeing the increase of a particular, and not of them are really good, and those ones are known as delirious alleles. So question number 5. Question number 5, let me kind of put it right here. Let's calculate the effect of inbreeding on the alleles. Consider that rare delirious recessive allele for a specific gene locus. In this hypothetical population, the delirious recessive alleles exist a proportion, and in a proportion of 0.01. As soon as you start talking about alleles, as soon as you start talking or seeing some sort of numbers, you need to figure it out. What do you need to figure it out? I'm talking about P. Are they talking about Q? Are they talking about P square? Are they talking about Q square? Or are they talking about 2PQ? That's one of the most basic statements you need to start with. what this number represents. Is it a P? Is it Q? Is it Q squared, 2PQ, or P squared? And in this particular case, it's the frequency or proportion of recessive alleles, or alleles, proportion of frequency of alleles. It's either P, it's either P or Q, right? So we know that it's not P squared, it's not Q squared, it's not either any of those. So we are either P or Q. Now it says recessive. The recessive got to be Q. So this is how we figured it out, that it's Q. As a matter of fact, if you read further down, the offspring to be homozygous delirious allele Q square, Q. So now we figured out what this is. So we know Q is equal now 0.01. Now we need to look it up, what exactly it's asking. It's asking what is the probable frequency that the offspring will be homozygous recessive. Homozygous recessive, also known as a Q square. So Q square is unknown. Can you find it? Of course you can. How do you do that? Well, Q square will be equal, our Q is known, 0.01, is square it, and that would be equal. We'll pull the calculator, 0.01, squaring it, and we'll end it up with 0.0001. That's it. Done. That's the probability. That's the frequency. So out of every 10,000 individuals, you will end up with one which has a homozygous delirious recessive allele. We can calculate P, we can calculate P squared, but it's not giving, well, it's not asking us to do. So this is first 5 questions. So if you submit just that, well, you will need to transfer it to a simpler form. Same questions, but without any of the explanations. So you will receive already like 30% of your grade. So about 30 points or so. 36, whatever the rubric is telling us. If you still have some sort of questions, you're not really sure where the numbers came from or anything like that, again, the recording will be available to you, or feel free to contact me like, hey, I don't understand where you got this one from. And I'll be happy to answer those particular questions. The question is, there is a question in the chat box, don't show work, just the answer. Well, I'm showing the work. And then this way I know the Q, and that's the answer. But for example, if you just put 0.001, if it's correct, it's fine. I'm fine with it. I will give you the full credit. But if, for example, you mistakenly missed 10 and it's just the number like this, then I don't know where it's coming from, and therefore I will not be able to say you don't know how to calculate it, or it was just be a slight typo. So I would recommend you to show the work, but it's up to you. It's your grade after all. If I'll see the logic, I can assign you instead of, for example, question 5. Let's say you showed me all that and your answer is this. Then I'll see, well, here is just a minute problem of plugging the numbers. This is the correct answer already. here probably just didn't type an extra 0. So instead of deducting all 3 points, I'll deduct only 1. However, if you are giving me as the answer just 0.01, I don't know where it came from, just the answer, and it's a wrong answer, so all 3 points will be deducted right away. So I would recommend you to stop, pause, and double check your work and show your work. But it's up to you. If you don't want to show your work, you want just the answers, you are very confident with your answers, fine with me. Any other questions? And that, by the way, is wrong. Speaking of wrong, this particular assignment is available on the internet source or resources. You can type it in and it will show you several versions of it with different answers. Some of those answers are incorrect. I beg you right now, do not copy and paste from the internet right away. Copy, paste, this is my answers. Especially when we start talking about the individual question. I am aware of that. And if I'll see that you copy paste it, it's a 0 right up, and yeah, we're going in a route neither of us enjoyed whatsoever. So please don't do that. You might want to use it as a reference resources, but I'm telling you, I've seen 3 or 4 different versions of it, and in 2, it has some wrong answers. So please be careful whatever is posted on the internet. It's not always the correct answers. All right, and please don't copy and paste straight from the internet. Don't do that. That's it's a really bad idea. It might fool me once or twice, but eventually it will catch up with you, and then we'll be having a really bad discussion. I'm just warning you. I'm not trying to scare you or anything like that. If you decide to go and you will not get caught cheating, that's wonderful. I mean, it's bad, but good for you. But in this particular case, again, please don't. I really don't like all of those. It's extra work for me, extra paperwork, and then it's negative emotions from the student getting an F, and yeah, it's I feel not really good about that to begin with. Have to do it, but I'm not enjoying it. Anyway, on that particular very, very optimistic note, we're done for today. Yay! All right, let me see. I'll stop sharing. I'll stop